Good morning. The topic I selected for this demo is reliable transmission, which is one of the important topic in computer network. Before starting the topic, let me introduce myself briefly. I'm Ikram Sayed. Currently, I'm working as an associate professor in Department of Information and Communication Engineering, Hankook University of Foreign Studies, South Korea. A little bit about my education. I did my BS from UTP Shower in 2008, and then I did my master from International University, South Korea, in 2013, and I have completed my PhD from Adu University in 2017. Then I went back to Pakistan and I started working in Azad Jammu and Kashmir Muzaffarabad University as assistant professor in head of software engineering department, where my responsibilities was Washington ICAD accreditation, OB implementation, and some other administrative activities. Then I moved to Superior University, Lahore, and I worked there for about a year. And then I moved to National Universities of Science and Technology, Islamabad, which is one of the best in Pakistan. And then I came back to Korea and I started working in Kachin University as assistant professor, and then currently I'm working as associate professor in Hankook University of Foreign Studies, South Korea. From last 2 years, almost 2024, I started working here. A little bit about my research activities. My research interest focus on MAC layer protocol optimization for wireless network, mobile communication, Internet of Things, and generative AI. Nowadays, I'm using for MAC layer protocol optimization. I also work in some research funded projects. One is from NRF, South Korea. One was from LIG. Next one, South Korea. And Asia Connect project was among 4 countries, and that's include Pakistan, South Korea, Malaysia, and Cambodia. It was a collaborative project. And one project was from internal from Kachin universities. I published around 60 articles, including IEEE transactions in IoT journals. I'm also involved in some editorial activities right now. Let's move to the topic. Uh, Reliable transmission. What is reliable transmission? um, to ensure that what the sender is sending, the receiver receive exactly the same things in the same order, no duplicate data, no corrupt data, and no packet loss. In this abstraction image, you can see that we have sending process, we have receiving process. The sending process is sending the data, and the receiver is receiving the data. And the sender and receiver using a reliable transmission. That is the abstraction. But the implementation is a bit different because in reality we don't have that the reliable channels in mostly. So if you want to make the unreliable channels and we want to get the reliable transmission, we have to implement some reliable transmission protocols, which we use the transport layer for that. In transport layer at the sending side and the receiver side, we are using reliable data transfer protocols to implement at the top of the unreliable channels. The implementation, the complexity of the reliable transmission protocols depend on the condition of the channels. So if the data is corrupted during the transmission, so we have to implement the checksum to check the data is correctly received at the receiver side or not. If the packet is lost through the channel, so we have to implement the acknowledgement in retransmission mechanism, or how to recover the data again. And if the data is receiving in out of order, so we need to implement the sequence number. So actually the complexity of the reliable data transfer protocols depend on the complexity of the channels, how much the channel is reliable, how much the channel is unreliable. So let's move to the reliable data transfer protocols. In reliable data transfer protocols, we have RDTs. RDTs 1.0 is the one that we consider that there is no loss, no data loss, no error So we consider that it is a perfectly reliable channel. So that's one of the simplest scenario. That's why we don't need to how to say explain it here. RDT 2.0 is the one that consider the error in the packets when the packet is receiving. So at the sender and receiver side, they implement at the receiver side, they implement if the data is received in correct form, they send the acknowledgement. If the data is not received in correct form, they send the negative acknowledgement to inform the user that the sender that the data you sent was corrupted. So that is also a little bit simple. So we have to we move to the RDT 3.0. RDT 3.0 consider the loss of data, the corrupt of data. So the data can be lost and the data can be corrupted. So let's explain that in some scenario, simple scenario. The first scenario we have here is that if there is no data loss. So in the first case, we have a sender and receiver. The sender is sending the data, the receiver is receiving the data. So the sender is sending packet number 0, the receiver received the packet number 0 without any error, without any packet loss. It's correctly received. So the receiver send the acknowledgement for packet number 0. Once the sender receive packet 0 acknowledgement, it send the next packet and so on. The sender is sending the packet, the receiver, once the receiver receive the packet in correct form, then it send the acknowledgement. But in us, that was the simplest scenario. In RDT 3.0, we will consider one scenario when there is a packet loss. When there is a packet loss occur from the sender side is sending the data, the receiver is receiving the data. So for example, the sender send packet number 1 and the data is lost. In this scenario, you can see that the sender and receivers might be far apart from each other, so they cannot see each other, so they cannot see the behavior of each other. So in this scenario, the sender send the data and the sender might think that the receiver received the data, but the receiver haven't yet received the data. So the receiver is waiting to receive the packet number 1, but the packet number 1 will not arrive because the packet 1 is lost in the middle somewhere because of the congestion. So now what the sender do? Should the sender wait for a longer time, or when they have to send the packet number 0 or packet number 1? For that scenario, the sender, we on RDT 3.0, they implement the timeout. So they use a timeout that we need a specific time period to wait for acknowledgement to receive. So when the sender send packet, they start the timer. For example, here when the sender send packet number 1, for packet number 1, the sender start the timers. And that timer, when the time is expired, they have to send another packet, or before the time expired, if they receive the acknowledgement, then they can send the data. So now the packet is sent from the sender side and the receiver haven't received the data yet, and the timer is expired. So what will the sender do? The sender will send packet number 1 again, because the timer is expired. It cannot wait for infinity time. It should wait for some time. That is a normal scenario when we send something to someone. How long should we wait for the acknowledgement? How long we should wait that the person receive my letter or not, the person is listening to me or not? So at that time periods, when the timer is expired, it had to send again the packets. And the same process, once the receiver receive the packet, the receiver send the acknowledgement. Another scenario here we will consider when the acknowledgement is lost. When the sender send the data, when the sender send the packet number 1, the receiver receive the packet 1, it's check the checksum, everything is perfect, it received the packet, it send the data to the application layer and then send the acknowledgement. So now the receiver think that I received the packet and I send the acknowledgement, but the sender didn't receive the acknowledgement because the acknowledgement can be lost. So in this case, the acknowledgement is lost. So how the sender would know that my data is received to the receiver or not? Again, the same thing, because at this time the receiver also think that it's already sent the acknowledgement. So the receiver had to start the timeout here once they send the packet. So packet number 1, when it's sent, it start packet number one timer. Once the packet number one timer is expired and the acknowledgement is not received at that time, they have to send again the packet number one. But at this case, when the sender send the packet number one, the receiver already received the same packet before, so it's a duplicate packet. It's a duplicate packet. So RDT 3.0 in this case, I had to discard the packet and send the acknowledgement, because now the receiver understand, oh, my acknowledgement was lost somewhere in the middle, so it's again send the acknowledgement. Once the sender receives the acknowledgement, and the process will continue again. There is another scenario that's because of the congestion, maybe the acknowledgement is delayed. So when the sender send the data, the receiver send the acknowledgement. The same case for packet number one. When the sender send the when the sender send the packet number one, the receiver receive the data in a how to say, in a correct form, and then send the acknowledgement. But what happened that this acknowledgement was delayed because of the congestion, and then the timer is expired before acknowledgement one is received. For packet number one, the acknowledgement one is received before that the timer is expired. So what the sender will do at this case, the sender have to send again packet number one. So the sender send packet number one again, and then once the receiver receive packet number one, it's knew that it's a duplicate package because it was waiting for packet number zero, and the packet number one receive again. So I have to discard that packet and then send again the acknowledgement. But before sending the acknowledgement here, the acknowledgement for packet number one is received to the sender side. Even it was for the old packet, it was the same packet, but before it was sent, when we send the packet number one. So at that case, yes, it's also indicate that the receiver received packet number one in correct form. So at this point, the sender had to send another packet. It wouldn't wait for the second packet number one acknowledgement. So it's here, it send the packet again. So now what will happen when there is sender receive the acknowledgement here? The acknowledgement is duplicate acknowledgement, act one, act one. So what the receiver sender will do, the sender understand that, oh, that is the one that's was delayed, and then I have to ignore this one because it already received act one. Now act one is again received, so I will ignore this one. And then when it send the packet zero, when the packet one packet zero acknowledgement received, and then they start the transmission again. Thank you so much for listening to the lecture. Thank you.